let's talk about batteries. They're in most of our daily use devices and even cars. Thanks to this component, we have the ability to use our phones or any other electronics on the go. In this video, we are going to see how do they work, which types can we choose from, and what we can expect in the upcoming years. Most widely used rechargeable batteries are lithium-ion batteries. Phones specifically use Li-ion batteries with LCO, lithium cobalt oxide chemistry, and in EVs is used NMC chemistry. When examining one, you'll notice several key components. On one side is the cathode, typically made of lithium cobalt oxide, or in the case of EVs, lithium nickel manganese cobalt. On the opposite side is the anode, composed of carbon graphite. Between these two components is an electrolyte made of lithium hexafluorophosphate, containing a separator, either polyethylene or polypropylene. Separator's role is to prevent short circuits by blocking the direct flow of electrons, allowing only lithium ions to pass through. This setup enables electronics and EVs to transport electrons from the anode to the cathode, thereby powering the device. When recharging the battery, the process is reversed. Electrons flow from the cathode back to the anode, facilitated by the charger. If you are interested in a more detailed explanation, check out the videos from Branch Education or Engineering Explained linked in the description. Now let's compare the two leading contenders in the phone battery industry. Lithium polymer batteries, or LiPo for short, are a type of lithium-ion battery that are widely used alongside Li-ion batteries using LCO chemistry in various applications. In this comparison, we will focus on LiPo and Li-ion batteries that use lithium cobalt oxide chemistry, as this is the most popular type in mobile devices. Determining which is better isn't straightforward, so let's explore the advantages and drawbacks of each type. LiPo batteries are a subset of Li-ion batteries, but they use different materials, particularly in their electrolytes. The primary difference lies in the electrolyte used. Li-ion batteries typically use a liquid electrolyte as mentioned previously. In contrast, LiPo batteries use a gel-like electrolyte which is safer due to the very low chance of leakage and swelling. This gel-like electrolyte is usually made of polyethylene oxide, also known as polyethylene glycol. The primary appeal of LiPo batteries in today's technology lies in their fast charging capability. Additionally, LiPo batteries can be molded into various shapes and can be made exceptionally thin, offering greater design flexibility. However, they have lower energy density and higher manufacturing cost compared to other types of batteries. In contrast, Li-ion batteries, while having a higher energy density and cheaper manufacturing cost, are prone to aging, which means they degrade over time even if they are not actively being used. Unfortunately, both of them use cobalt, which is unethically mined, and lithium, which has a negative impact on the environment. When it comes to batteries for cars, the favorites are nickel metal hydride batteries, or NIM for short, that are mainly used in HEVs, and Li-ion batteries using NMC chemistry, which are used in EVs and PHEVs. NIM batteries have a cathode made of nickel oxyhydroxide when charged, which reduces to nickel hydroxide during discharge. The anode is made of a metal hydride alloy, and the electrolyte is typically a potassium hydroxide solution. NIM batteries are cheaper to manufacture due to the lower cost of materials. They perform better across a wider range of temperatures and are safer because they contain fewer active materials. However, NIM batteries have a lower energy density, a shorter lifespan, and charge more slowly compared to Li-ion batteries using NMC. Despite these drawbacks, NIM batteries are generally more environmentally friendly. In the future, there could be several alternatives to current battery technologies. Let's explore these alternatives and compare them to Li-ion batteries. First, consider solid-state batteries. The primary difference between solid-state and Li-ion batteries lies in the electrolyte, which is solid in solid-state batteries. Potential solid electrolytes include polymers or ceramics such as oxides, sulfides, or phosphates. This type of electrolyte also functions effectively as a separator, allowing only lithium ions to pass through. This enables the replacement of the carbon anode with a dense lithium metal anode, potentially offering higher energy density, faster charging times, and longer life cycles. As a result, electric vehicles could achieve greater range with the same battery size, charge more quickly, and have an extended overall lifespan. Additionally, the solid electrolyte significantly enhances safety by eliminating leakage and reducing the risk of battery fires. Another substantial advantage of solid-state batteries is their reduced reliance on cobalt, a material often associated with unethical mining practices. However, one disadvantage that remains from Li-ion batteries is the continued use of lithium. This disadvantage could be fixed by using sodium-ion batteries. Those batteries don't use lithium or cobalt at all. The main difference is the replacement of lithium ions for sodium ions, and lithium salts swapped with sodium salts in the electrolyte. They're in the same group in the periodic table, so they have very similar characteristics. Sodium is also way cheaper to get and way more abundant than lithium. They're also very safe as solid-state batteries mentioned earlier, and have higher life cycle. They can be transported fully discharged, thus making them safer to transport. Unfortunately, sodium-ion batteries don't have as good of an energy density as Li-ion batteries do, so they have to be bigger and heavier in comparison with Li-ion batteries with the same capacity. Batteries will definitely be very important in the future with electrification of everything around us, unless scientists find a new revolutionary technology that will change the course of our future on this planet. I hope you've enjoyed this video. If so, please make sure to like and subscribe. If you noticed any mistakes, have recommendations on how to improve the videos, or have ideas for topics I should cover next, please leave a comment down below. That's all from me, and see you next time.